Hello everybody, Mike here at Game From Scratch. Welcome back to our ongoing Armory game engine tutorial series. Today we are going to be looking at handling, specifically mouse and keyboard handling, although the process is pretty much identical for other means. We'll get into those in more detail down the road. We're going to be looking again at both Haxe and node-based programming in this example. And as always, this is also based on a text version that is available over on DevGame. It is the handling input one that we are going to be covering, and I will throw that link down below. All right, without further ado, let's jump right in. Now, obviously, you need to have your Armory version up and running. Here you can see I've already created my project. I've already switched to the cycles renderer, and I have done a build of my scene. So we are ready to get started. The first thing we're going to do is actually tweak our camera slightly. We're going to be moving things around, and it's a lot easier to move things when you can see it from like a straight on side angle, and you've got a fixed set of coordinates going on. So just hit the end menu, bring it up here, select your camera in the world, and what we want to do is just move this guy. We're going to move our camera to 0, 0, and negative 15, and we're going to change its rotation to 0, 0, and 180. Just like that. So if we come down into the scene, we hit 0 for our camera view, and you can see that is what we're working from. So this way, it will give us a better idea when we move things around how we are moving things. Whereas if you're looking from a perspective angle, it can be a bit confusing at times. All right, with that little bit of housekeeping out of the way, let's look at how you use the keyboard to cause, well, what we'll do is we'll translate this cube in the scene using the keyboard. And I'll just repurpose my timeline down here. So I don't need tools or properties anymore. Turn both of those off. Go to the timeline here, and let's open up our node editor. Okay, we'll switch over here to logic mode, and we create our new node tree. And we'll call this guy, I don't know, keyboard node controller. All right, and now that we've got that, let's go ahead and actually handle keyboard events. Now, this is actually really, really simple. Oops. We saw earlier on that we were using events to control things. So when things started up or on event or on timer, etc. What we can do in this particular case is a very similar thing, but instead we're going to go to input. Now you're going to see here there are two sets of things. There's keyboard and then there's on keyboard. Well, when you're dealing with input in any game engine, there's basically two approaches you can take to how you're going to deal with input. You can poll for it, which is basically like a loop. You can go, anything happen? Did anything happen? Anything happen? Anything happen? Anything happen? And eventually game engine will go, oh yeah, someone moved the mouse. And then you'll respond accordingly. Or you can say, hey guy, when something happens, let me know. And that one is event driven. So basically the game engine is going to raise an event when input occurs, and our code is going to respond accordingly. And that's what we're going to demonstrate right now. And for events, you want to find these on events. So the one we're going to deal with first is on keyboard. So when a keyboard event fires, this will happen. And it's a little confusing. Events, these input on events, these 5 right here, could just as easily exist in the event category. It would make sense for them to be in either place because these are straight out input events. They've got nothing to their left and they start things off. So we create our on keyboard like so, and I'll zoom in and I'll show you what I mean. So we have an out, but we have no in. This is a source level event. It fires off and starts a process going. And once we've got that, we've got a couple of options on it. So on keyboard here, we can choose what we respond to. Now you've got started, which basically means when a keyboard is first hit, down, which will fire over and over and over again as long as the key is held down, and then released, which is when the keyboard is let go of. So if you think about it, a keyboard press is actually two things, a touch and a release. So that's generally, if you only want to respond once per key press, you would generally use release. And then finally in this one, it's pretty straightforward. You just pick the actual key you want to deal with. So in this case, I'm going to handle the right arrow key, so like so. And all we're going to do is a very simple translate on local axis again. So you see here our local axis, the x-axis is this way and that way. And we're going to go ahead, add a node. It's an action, translate on local axis, like so. So this one obviously has an event input. We wire our output from the on keyboard event into that event. We can pick our object right there. So we picked our cube, or we could click the list and select from all the objects in the scene. And then now it's a matter of picking the speed. So let's go to 0.2, and forward is 0, up is 1, right is 2. So we want 2, like so. And now, in theory, this guy should be ready. So I'm going to do a save. With my cube node selected, I'm going to head over here to properties. I'm going to go down to Armory traits and add one, a node-based trait, and wire up our keyboard node controller. In theory, I'll press F5 and run my game. And when I hit the right key, I go backwards because I have my axes set up wrong. Okay, 1 second. Oh, actually, my axes are set up fine. My error was actually here. So to go right, we select 3, not 2. So there you go. We have on our keyboard event, so when you press an arrow key, we now move on that given axis. Go ahead and run that. And there you see, when you hit right, it moves accordingly. Now, I'm holding down the key, and you'll notice nothing is actually happening. Now, what I'm going to do is show you how down works as contrasted. So I'm going to switch release to down, and we're going to move this speed quite a bit down. We'll make it 1/10 of what it was. And now I'm going to go ahead and run it again. This time I'm going to hold the right arrow key down so you can see the difference. So last time it only moved once. Now it's going to be a constant movement. So that's the difference between the down, the released, and the started. Now the started versus the released is going to be up to you if you want to handle it when the key is first pressed versus when the key is released. And there's real functionally no difference between those two or which option you decide to go with. So that is the very basics of keyboard handling, but that applies to all keys. You basically use the exact same logic. And if you have, more process, you basically keep stringing them on here and out you go. So that would be the on keyboard event. And you can have multiple on keyboard events in a node graph for all the various different keys being handled. So you don't have to branch this off or do anything special with it. Just create more of them. Now let's look at dealing with 2 keys. So now what we're going to do is change this graph up a little bit so that if you're holding down the space key and the right key, actually we'll do the left key. We'll switch this out to the left key. So I'll show you how the inverse works. So we're going to switch to left key. So we're going to want to move left. But if the space key is down, we're going to move more left. So in order to pull this off, break that guy out there. So we've got our key. This is the event that's going to fire everything off. But we also want to pull our keyboard's current status. And we can do that here with the add. And we go to input. And there's the, so while there's the on one, this fires event, this one instead just checks the status of the keyboard. So we're going to add a keyboard event here. And we'll stick with space. So if the space key is currently down, and this event fires, then what we're going to do is move faster. So we'll stick with this guy for the 1. So this is, we'll switch this back to released. We'll switch this back to 0.2. Actually, I'll go with 0.1. 0.1. And here we're gonna go left this time instead of right. All you do is actually inverse the direction of the translate on local axis, and now we'll go the opposite direction. So instead of right, this will go left. All right, so we have our keyboard event comes in here, and our spacebar. If the spacebar is pressed, we're going to go faster. So in order to pull that off, well, we're going to need 2 translate options. So let me just zoom this guy out a bit. We'll grab this guy here, do a Control-C, Control-V. So we have another one. And we will increase the speed of this guy to 0.4 instead. So if the spacebar is down, we want to do this guy. If the spacebar is not down, but a key is pressed, we want to go ahead and do this guy. So now all we need here is a branch. So you can actually search for nodes right here and type branch. Type it correctly, it works better. So we've got our branch. We'll create that node. Came in off screen for some reason, but we're bringing that down. So this is a true or false. So state of the keyboard comes in as a bool. Our keyboard on keyboard event comes in here. So if this is currently true, like so, we will go fast. If it is currently false, we will go slow. And it's kind of showing you the basics of how logic works in your Armory games. Go ahead and run this. Now you'll see, I think I'm missing a 0. We went very, very fast off the screen there. So let's, oops. All right, that was my mistake. I kind of wired the input event to the speed event. Let's try that again. So with it properly hooked up, I press left. You see we've got slow left movement. Now if I hold down spacebar and press left, each time we press, we move even faster. So that shows you how you can handle branching in your situation, and also how you can pull the status of the keyboard. And you can do this, you can pull this in any kind of event. It doesn't have to be in an on keyboard event. This could be on init, on output, etc. And this is an example of pulled input, where this is event-driven input. So you can actually mix and match the two together like we just did right there. Now let's switch things over and look instead at the mouse. Now the mouse is, here, I'll just Using the X key, I'm just going to clean this node tree up, get rid of everything. All of a sudden, this name is not going to make a whole lot of sense, but I'm fine with that. So now we're going to wire up mouse events. And the mouse, we're going to go ahead and go and create an on mouse event. So input on mouse. And what we'll do is we'll fire this one on moved. This shouldn't matter, but I'll set it to middle anyway. So basically, whenever the mouse is moved, this event will fire. And what we're going to want to do is move our cube, but we don't want to move it just willy-nilly. We're going to actually do a bit of logic here. So we'll come up here and go add action translate object. So our cube is still selected, so let's go ahead and pick it right there. And now we're going to do a couple things. So we've got that the fact our mouse moved, but now what we need to know is actually where it moved. So we're going to go ahead and add another node, go to input, and we're going to say mouse coordinates. So right here, and what we're doing is we're wiring, we're going to get the movement coordinates right here. Now, we don't want to move by the amount that our mouse moved, or we're going to move really, really fast. So we're going to multiply that down. So we're going to bring in a vector math, excuse me, value, vector math, like so. And we will bring in our movement right here. And we're simply going to multiply it by a much lower value of 0.01, 0.01, 0.01. Actually, I think I just did a comma there, so let's make sure that worked out right. Oh, and enter. It's finicky about that, by the way. You can't just tab away, which is annoying. 0.01, enter. So you can see we're basically taking a 100th or 1% of the amount that we moved. Now, movement is relative to the previous frame, whereas this would just straight out give you the mouse coordinate on screen. And now that we've got that, we actually only want the X and Y values out of here, like so. So we're going to do another operation here. So we're going to add, and then we're going to do separate X, Y, and Z. So we're going to split this guy out. So take the output from here, like so. And then we're going to create a new vector from that. So add variable vector, like so. And we want our Z value to be 0, but we'll just take our X and Y value out from there. And then we'll finally plug that into the vector. So we say on our mouse move, we're going to translate this object by this vector. And this is basically, we pulled the mouse for its current coordinates by the amount that they moved since the last frame. We minimize that value quite a bit, take the X and Y value, create a new vector out of it, and we're off to the races. And now let's go ahead and run that. And you'll see as whoa, I did something wrong. 1 second. Oops. Okay, I forgot to change one field. Right here, I didn't want this to be an add. I want this to be a multiply. Okay, now we'll go ahead and run. Because basically what we did when we were adding it is we made the coordinates really, really big, whereas what we're wanting to do is multiply it by 0.01, so we're turning them to like 1/100th of their current value. So now when I move the mouse around, our object moves in the corresponding axis, like so. Ta-da! And that is the basis of dealing with the mouse. Now, we haven't covered one thing here, and we'll cover it in the same example. We haven't done anything for when the mouse is actually clicked. So let's do something there. All we're going to do is set the location of our cube back to 0, 0 when the mouse is clicked. To show you that you can actually do multiple ons in a single graph, let's do exactly that. So we'll come down here, and we will create a new input. So I want an on mouse right here. And now we're going to pull for the buttons. So we're going to do on release. And this works just like you saw with keyboard, except for there is a moved event, which we use for moving around the screen. There's also a released, started, and down. Those are the same deal as started is when you first start clicking a mouse button. Down is when a mouse button is actually held down and will repeatedly fire as long as it is held down. And released is when it is down and back up. I will fire with released, and we will fire off. The left mouse button is fine by me, like so. And then in the event that this happens, we're just going to go ahead and do a set location. So add action set location, like so. And we'll wire that guy to that guy right. Oops, I missed that guy right there. We will use our currently selected cube, and we will set the location to 0, 0, 0. That works for me. Go ahead and run that. And now you will see we pan around like so, and then I click and we go back to the 0, like so. So that is the simple example of using both the keyboard and the mouse in the node-based programming language in both a polled and event-driven style. Now let's move on to show you one last example, and that is generic events. Now this is handy when you want to have multiple inputs doing the same thing. So let me just do a box. I'll grab everything here and hit X, like so. By the way, B is box select, so then you can draw a rectangle around things, and X is the delete key. So now that we got rid of everything, let's go ahead and make everything again. So what we could do, I'll do it just showing you a couple of examples. It's more in depth on the text-based tutorial, so if you want more details, do check out the text tutorial I've linked down below. But I'm just going to do 2 on keyboard events for the same thing. And this is a very common thing you want to do in a game. So input on keyboard. So I have 2 on keyboard events here, and what you often will have is, for example, I want to move left or right. So I want to move left whenever the user presses the left arrow or the A key. And you could also have it that if they press the gamepad, here, I'll get rid of this one and make this one a gamepad so I can just show you it. Add input on gamepad, like so. So on gamepad works just like we've seen with the mouse and the keyboard. Released. And then we'll do the left D-pad, right? So if they've pressed and released left on the D-pad, or if they've released the left arrow key. So in these cases, we want to fire the same basic code. Well, how do we do this? Well, the easiest way is basically to connect both of these to a similar event. So we'll just come up here and we will do action, and then we want send event, like so. Now we can wire this up and we'll say move left. And then I'll do a Control C and a Control V. So I've got, oops, come on, Control C, Control V. So I've got 2 of these nodes, and we just wire each one in like so. So what we've done is whenever the user presses the on keyboard event, we fire off this generic event called move left. When they hit the on gamepad event, we do the exact same thing. So now we can do either in the same script or somewhere else, we can do a generic under event. You do on event, like this. You put your move left event right there, and then you could handle it generically however you wish. So this is where you put your implicit, handling of this process. And here you can have as many event handlers firing the exact same event as you want. And this node tree works however all the others have worked. So then you can have it go ahead and say translate left, and then either pressing the keyboard left or the gamepad left will fire that exact same event, and everything from this point on lower will then get triggered. So very useful for making generic event handlers for multiple event sources. And the final demonstration in nodes, let's just get rid of everything here. So box, select everything, go ahead. We can also do our update in the on update event. So this is true polling. So what we do is just do in your on update, like so. You can trigger it out and have this go off to do whatever you want. But first we'll just drag that guy off to do an is true, available right there. All right, like so. So then you can bring in your other events like input, and then not the on event. This is an event, whereas this is a poll. So we're gonna just basically say, hey keyboard, is the space key currently down? Like so. And then this code, whatever's on this end, will only fire when this condition is true. And of course, you could create much more complex layered examples of polling, so you could check for multiple conditions to be true, etc. But this is how you could do polling. So basically do it part of your on update callback. And remember, on update is called every frame over and over and over again as the game is run. Which style you want to use is completely up to you. You can run into a really big graph of on update if you do things this way. So handling your events in separate node graphs is probably a cleaner way to do it, but really it comes down to how you want to structure your code. There should be no real performance difference between the different options. So that is input handling. Pretty comprehensive stuff we've done there from a node perspective. Now let's switch over and do it from the Haxe perspective. We're going to do this all in one single example, and it'll actually go pretty quick. So let's do that. So first off, I want to just go ahead and disconnect this guy. So let's just delete him there. Go back to Armory traits, create a new one. Like so, this is a Haxe trait. New script. I'm fine with new script. Okay, so we've just created our new script. Make sure I save my scene. And now we'll go ahead and edit said script. Now, let me just get rid of the Explorer so you can see well. Zoom this in a little bit. All right, hopefully you can see that just fine. Okay, let this do its thing for a second. All right, so now we have code completion and we're happy campers. Excuse me. So now what we're going to do is we got a couple of options here. We can implement things in on update. So this is that whole pulled event. So every time we're update, we could check the status of the keyboard and handle things accordingly. And let's start with that one. So first off, grab these two lines and we're going to uncomment them. Coincidentally, in code, you can use control and a / and it will uncomment commented code. Like so. So remember, on update is called every single time the game loop runs. So now we need to get access to the keyboard. Well, this is pretty straightforward, and this is where Iron comes in. Now, Iron, you can think of it as the bridge between both Armory and Blender. So this is kind of how you get your data from the scene and your data from the game engine. And we're just going to do an if. So Iron, and then we're going to use the system. And then inside a system, we'll use the input. And then inside of input, we'll get a reference to our keyboard object, calling get keyboard, like so. And now we're going to check to see if the person released the key. And then we just check which key we want. And we'll go with space. Now remember when there was that entire list of keys we could choose from? Those strings match these strings right here. So if you need to look up what a key is called, such as the space bar, it'll be in that pull down when you select a keyboard event node. So that's the string we're going to go by. So that's the end of our if statement. So we're good there. So this code will fire if the person presses the space bar. Now we're not going to do a whole lot fancy with this demo. Try to keep time down a bit. So all I'm going to do is trace out space bar pressed, like so. We should be good there. So that is how you could check to see if the keyboard is pressed. Now checking to see if the mouse is pressed is just as simple. We can do another if here, and I'm betting you can guess part of this. System.input.get. You've got all your other input devices available there. So in this case, we'll go with get mouse. And we'll do a released again. It could just as easily have been a down or a started, or the three different states that are available. And we're checking for left, like so. And if that's the case, so if the user has pressed the mouse button, we're going to trace out a little bit more detail. So trace left mouse button clicked at. And then what we're going to do is dump out the coordinates. So, oops, a bit of an error there. I want released, not release. So we're just going to go ahead and now put the x coordinate. So iron.system.input.getMouse.x plus, just do a comment there for looks, and then iron.system.input.getMouse.y plus, let's close that off and close my trace, and that should close off my function. All right, theoretically that is done. I'll do a save here and we will run this code. There you go. So now we're on screen. And every time I click the mouse, you'll see in the background the various different coordinates that the mouse was clicked at being printed out as we go. So that is handling the mouse via polling and the keyboard via polling. So how do we go about handling event-driven? Well, right in Armory, there's no direct event handling ability built in, but in the underlying CAW framework there is. So that's what we're going to use today. So what I'm going to do is just come down here and create two function pointers, and I'm just going to copy and paste them so that you don't have to see copy and paste coding in action. So basically we've got an on key down function we're defining. So this is basically a variable of a function. And what it is it takes a type of key code and returns a type of void. And all we'll do in each particular case is either trace that the key is down or the key is up. So now in order to implement this, well, we actually want that init function I kind of destroyed earlier on. Oops. So let's bring that back. Notify on init. And again, this is a function like so. Let's just close that guy off so that it's actually working. And then we want to just register our two callback functions. And this is done using caw.input.keyboard.get. And then you want to use the function notify. Now, notify takes 3 parameters. The last one is optional, and we're not going to be using it today. The first one is a function that will be fired when when any key is pressed down. The up is fired when any key is pressed up, so we'll have to put logic inside to handle each individual key. And then the final one is to search for a certain string combination press listener. And again, we're not going to use that one, and that one is completely optional. So we're going to pass in on key down, we'll pass in on key up functions like so, and use the right thing. And now we're going to go ahead and run it. So this is going to just, we've registered these callbacks on init, but then they'll be there forever. So if you want to get rid of them, you have to actually remove them manually. But we'll go ahead and run this. Do. Bum, 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 bum. All right, there it is finally. So there's our game running. And now if I press a key, so there you see, I just press the A key and it gives me the ASCII character code for that key. So A is obviously 65, B is 66, C, D, E, F, G, H, I, J, K, L, M, and so on. Shift, Control. So you're getting the key both a down and an up event as they are fired. So obviously you'd have to build up some logic on top of this to check each individual key code and respond accordingly. And Caw has all of the key codes mapped. There are variables in place for doing those checks as it is now, so you don't need to roll that yourself. And essentially that is all we are covering today. There's quite a bit in there. From the Haxe side of things, it's a lot faster to explain. But I think you get the idea of how to do both pulled and event-driven keyboard input in both Haxe and nodes at this point. Plus, we saw a little bit more about how to do logic programming, how to make generic events. That's reusable. That send event stuff can be used in just general game programming. It doesn't have to just be used in input events like we've done today. So I think we actually learned quite a bit today, and hopefully you did find that useful. If you have any comments or feedback, etc., do let me know down below. Also, if you've got specific things you want to see covered, or if on input I missed something specifically that you were interested in, please also do let me know that down below. And stay tuned for the next tutorial. It is going to be on sound and music, and there should be some new text tutorials up on DevGame very, very soon. So keep an eye on it. And as always, those links will be down in the comments below. All right, talk to you all later. Goodbye.